Good afternoon. Woo! Yeah, we need some energy. It's Friday. It's been a long week. We've had a lot of, hopefully, good presentations. I'm sure you've seen a lot of orange shirts walking around lately. We decided that the orange was the best because it epitomized what we shouldn't be. This is the worst style we could come up with, and so really it's out there. So you guys are here on Friday, the last day of the PDC, coming to a deep architectural talk about Avalon, and really you're the kind of people who decided not to go visit the stars home today, not to get home early, but really you want to dive in here. And so we want to make this talk be about what you guys want to hear about. The format we're going to do is we're going to spend about 30 minutes going through a slide deck, talking about kind of the overall picture and shape of Avalon, how the systems fit together. Then we're going to spend about 45 minutes with whatever question you want. We're going to have Greg Schechter and Jeff Bogdan come up here, and we're going to drill into any portion, any depth, anything you want to hear about. If you want to know how we... Okay. So then with that, without further ado, we'll move on into the, we at least have one person who's enjoying the topic. So, oh, and of course it's Miguel, so that's even better. So, okay, when it's another presenter clapping for you, you know it's not going well. So this is kind of the high-level overview of the low-level parts of Avalon, if you would. Most of the talks you've seen so far this week have focused on this very top bubble, the element system. So if you think about this whole picture as the anatomy of Avalon, if you're walking around, if you're a person breathing in and out, you just you don't think about it, right? You don't think about the skeletal system and the muscular system. Really, you only kind of see the exterior of the person. And the element system is kind of the exterior of Avalon. It's the thing that's the user interface. It's the face and the hands and all those parts of the body. And there's all these things below it that kind of make that work. And so as opposed to getting into the depths of the element system where we see styling and layout and all of this stuff, we want to talk about these other pieces. So the first one that's kind of the most interesting to talk about is the property system. So the property system does really kind of three main features. First off, it does change notification. So if you think about this doesn't sound that interesting, it's not that important, but it's really the basis for everything else you hear us do in the system. When you create a property and you want to support anything like data binding or templating, you have to know when someone's modified that property. And today in using .NET 1.0 or 2.0, you basically have to write a bunch of boilerplate code. You have to go through and say, well, if this property has been modified, I need to do this thing. And here, it's just built into the system. So if you went to Kevin's talk about writing custom controls, he showed these lines where you declare dependency properties. And by using that dependency property system, you plug in here, and you get this built-in change notification. The second problem, or the second thing we needed to solve with the property system, was really this notion of storage. So in Avalon, we wanted properties to be the main programming model for the system. We wanted you to be able to style properties, trigger changes based on properties, affect the look based on properties, which meant that a bunch of stuff you used to do with code and writing imperative stuff would now become declarative. But when we did that, we had a problem of storage. The topography namespace, all that cool type stuff where you can do hyphenation and cool justification and ligatures, it introduced 40 new properties to every element in the system. If we had made that all be local storage, the performance would be absolutely abysmal. We would have every element taking up, half a megabyte. It just would have been ridiculous. So we have, in the property system, a sparse storage system. So when you declare an Avalon dependency property, you'll notice that you don't actually create a local member variable. Rather, you just call the helper methods inside of it. That is to get that. And finally, we needed a point of extensibility. So we have expressions. So when you declare a data binding, the property system actually creates an expression object for you. And it's what does the heavy lifting of moving data around the system. So styling, inheritance, data binding, all is based upon this engine, this notion of expressions in the property engine. So we've got our properties. We've got this element system. We need to get input. We need to get data from the user. We need to get, to let them be able to click on us. And so what we have is a extensible input system. Now, this may sound a little like, well, duh. You're running on top of Win32. You get WM-click, you get, WM-char, you get the 42 flavors of WM-IME, blah, blah, blah. But in Avalon, we wanted to have a nice, clean, succinct model for this. And we wanted to have a better way of plugging into the system, a better way of dealing with the element tree, with dealing with modern input like pens and remote controls, etc. So we have this input system that takes care of that for us. And it also allows us to plug in a commanding system deep in the bowels of the system. If you've used Win32, there's basically one command thing you can do, WM command. It sends a message to his parent, says, hey, I want to do this thing, and the parent can do something. Which is great, but it's not very extensible, and you can't do the modern types of thing you want to do with applications. And so our input system natively understands commanding. So you can have a notion of a bold command. And the wiring of that to an input gesture like Control B is done effectively declaratively in your class as opposed to having to write code to handle that. So we have this input system which can send these events. But if you went and you looked at the element system, and we've talked a lot throughout the conference about this notion of composition. You create elements within elements within elements within elements and ad nauseum, right? Does it ever end? No. We're looking at creating the pixel element, but that'll come later. The event system needs to handle this notion of routing. When you get this big, complex graph of elements, you need to be able to have things traverse up and down the tree in a very meaningful and simple fashion and consistent. So what we did is we have a general way of routing any event throughout the entire tree, which is, if you're familiar with Win32, is a lot like WM Notify, which allows you to go talk to your parent and say, I want to give you this piece of data, I want you to do something and talk back to me. And here we have a common way that this works throughout the entire system and any level of hierarchy of depth, which, if you've used the DHTML event system, is something they do in that natively as well. Then we had, again, this notion of performance problems. So the performance problem of moving to a purely delegate-based approach, a pure model where you're attaching listeners all over the system, you get into this issue where you again get to this per instance cost. So just like in the property system, we needed sparse storage to allow you to use properties but not have a massive performance overhead. In the event system, we needed this notion of class handlers, the ability to say, for any instance in the world, I want to listen to this event, which for common things like, for example, typing text in a keyboard, we know that we always want to handle those events for anything that's a text box, so we can declare that at the class level as a static listener to the class without having to incur any instance overhead. All right. So we've got our input. We've routed the events around the system. We have a base data model in the property engine. Now we want to get some actual text on the screen. We want people to be able to read what we're saying. So we have a font system. The interesting thing about the font system is that we really rewrote the guts of our text engine in Avalon. So we've really had about 2 large font engines throughout kind of history in Windows. We have the GDI engine, which we all know and love, and it renders text incorrectly in most languages. And we came up with a new one a couple years back, and we have this thing called Uniscribe, which allows you to go in and actually do locale-aware text, and you can go query it about various runs. You can figure out actually where to put the glyphs correctly so you can have a chance of getting it right. But it was super complex to do, and it was really hard for anybody to actually extend it or use some more advanced features. So for Avalon, we knew we had to rewrite this. So the font system is something that takes true type font files of any type, open type, basically true type or Adobe CFF also, and creates the necessary information about them, the metrics, the glyphs, and caches them. So the really interesting thing about the font system, it's the first piece up here that actually runs out of process. So if you run on a box with WinFX installed, you'll see that it has something called presentation-font-cache.exe running. Right? Did I get the name right? Just making sure. Okay, everybody's nodding. And what this is, it's the per operating system cache of all of this information. It's really expensive to calculate out the paths and the metrics about the individual characters, so we cache it and then use inter-process communication to get the data back and to get the data into the process that's rendering the text. So you'll notice an interesting thing about this is that the font system is both used directly by the element system and the visuals. So if you were paying close attention as we were going through, in the bubble for the element system, I said that it handled text layout. You'll notice I also say at the visual system we handle text layout. This is because there's actually two different kinds of text layout going on in Avalon. There's a high-level kind of page level, which we call page and table services, or PTS, because we love acronyms, as you've seen by all the new names for our products. So we've got this PTS level stuff up at the element layer, which needs to know about paragraphs, bolds, tables, a lot of GUI, a lot of object model, a lot of hierarchy in it. And then at the visual system, we have a simpler model for dealing with multi-formatted text on a line level, or a single paragraph is what it comes down to. So both the visual system and the element system have to go in and talk to the font system to get data about how to lay out those characters. Make sense? Visual system's also where we get the entire exposure of all the 2D and vector graphics and animation and video and all the cool stuff that is, gives us all the flying pixels on the screen. But it doesn't the visual system doesn't really do much work, in fact. What it really does is talk to, sorry, no offense. What it really does is talk to this transport, which is a remoting protocol that takes messages and can transfer them across a boundary. It takes all that and communicates to the composition system, which this is the true deep workhorse. This is the thing that actually takes and says, I'm going to calculate all the pixel colors, and I'm going to do the rasterization of the lines, and I'm going to take that shape you gave me, I'm going to create a bunch of triangles. Triangles are interesting because the composition system is actually talking to a 3D video card. 3D video cards basically understand one and only one thing, which is a triangle. So whenever you see text or paths, everything, it all gets decomposed down into lots and lots and lots of little triangles. And this allows the whole thing to be hardware accelerated. In addition, we have an implementation in the composition engine of a software renderer. So in the cases where we don't have a hardware part that can handle all the 3D graphics, we actually can just render with software. The other interesting point, if I pop back to this transport, is that it's remotable. So you can actually take this transport and run the composition engine on a different machine. So if you think about this in terms of what can be done from a terminal server scenario, you could actually use the hardware on the client when talking to a server, which is definitely one of the areas that we see as a big benefit of going to this kind of structured architecture like this. All right. So that's the big picture. That's the general set of services. It's a general set of things we have. And what I want to do now is kind of walk through how all this stuff plays together. How do you write a program? How does a program execute? How do we really get pixels on the screen? How do we talk to the user? So we all know this step. This is the step that you all understand, and we've talked about a whole bunch of times. You write a program. How do you write a program? Well, using the one and only one language of the universe, which is XAML. We've all seen the XAML something like this. You have a list box. You're going to create some classes. That's great. And you run the compiler. And the compiler inserts magic here. And you get an exe on the other end. Well, the interesting thing about that is that there's this little intermediate step that is our little dirty secret of Avalon, which is we actually do a lot of work during the compilation. Not only do we create the C# file that's going to be your code behind, that's going to do that glue for you, we also create a binary version of that markup that we call BAML, because we can't think of another three-letter acronym, so we had to go with 4. And what this is not a random number of ones and zeros like you see up here, but rather a very fixed set of things. It's a binary object model that represents that XAML. It allows us to more efficiently parse. It does all the type resolution. And we now have, it's still a declarative format, but it's a binary declarative format, which gives us a much better performance when we load it. We take that, we run it through C# or VB compiler or whatever, and we spit out an exe on the other end. Right? Interesting, simple. We've got our bits, we've got our BAML, we've got our markup. We're now ready to run. We execute, we jump to the right instruction set, we bootstrap the CLR, we go through, we run through, we call application.run, which gets your message pump up and going. We need to make the pixels blink. So we instantiate your objects. XAML is a way to instantiate objects. The list box tag one-to-one maps to a list box object. And so you can go and we can instantiate that. We can set properties on these. We can wire these all together. And we create a graph that looks something like this for the markup we saw. But again, here we'll go into the lie. The lie that we tell with XAML every time, which is a lot more happens here. First thing is we try to measure and arrange this stuff. If we're going to make the pixels blink, we have to figure out where to put the pixels. So we ask these things to lay themselves out. In Avalon, the layout system does two passes. It does a measure pass, it does an arrange pass. When it does this, we figure out that we need a template. We need to make the UI. We need to make the display for this. So if you went to Robbie's talk on styling, we talked a lot about how this binds together and how you can declaratively change the look. I hope you guys are going to smack me if I credit the wrong speaker with the content. And so what happens is we create another set of elements, which we call the visual tree. The visual tree is really nothing more than another element tree that's representing the visualization of that UI. And this goes on, because a scroll viewer actually consists of a scroll bar, and the scroll bar actually consists of buttons, and buttons actually just goes on and on. But the important thing is that we use this one mechanism of templating to create all of the display that you see. Everything ends up resolving down to a series of elements. Even when you get into something like data binding, where you can put an object directly in your tree, like a person, we figure out a way to create a set of elements for that tree, for that object. Eventually, we're going to have to actually render the bits. We still haven't got pixels yet. We're still dealing with meta objects of these XAML elements that have all this styling and goop on it. And we want to get to the metal. We want to figure out how these pixels are actually getting on the screen. So we call render. And again, render sounds like we're ready to talk about pixels. But no, alas, we're not. We're still talking about objects because we need to be able to remote this, right? We talked about that transport layer. We want to keep this in a declarative format that we can move between machines. So when you ask a control to render, the easiest one to think about is an image. And an image actually needs to call an instruction that says, draw these pixels. What it does instead is it creates what we call render data, which is a little binary blob that goes through and it has an instruction stream. Phone, you can answer that. You create an instruction stream. It goes up here. Oh, Marshawn, you're wearing an orange shirt and you got your phone on. Oh. So we create this instruction stream. And this instruction stream is really the IL of Avalon. It's the thing that describes the instructions we're actually going to paint to the screen. We even have an object model for it, which is called drawings. And drawings are really a lightweight object model on top of this binary stream. You can think of drawings as the reflection API on top of our rendering instructions. We're getting close. We're getting close to real pixels, because what we need to create is this picture. So we had all these elements, all this goo. We've talked about it a lot at the conference. Now we're really getting to something that I don't believe we've talked about on any of the other sessions, which is the composition nodes, the actual bits that we're going to use. These are, may I say, unmanaged data structures. It's scary. In Avalon, there's an unmanaged composition engine. You'll notice that we create a graph that has a set of trees, and they have data associated with them. Those little square boxes are supposed to be the same shape that we saw in the previous picture, because they're the same set of data. They're the same rendering instructions. So what we do is we know we need this tree on the right, and we need the tree on the left. So we're going to go between those two trees, and we're going to translate everything from one to the other. You'll notice at the top, I have two interesting things, a UI thread and a render thread. We've talked a lot about how Avalon is a single-threaded UI model. Just like Win32 was, we have STA dependencies. We've had lots and lots of conversations about if we could ever get away from that. But for now, let's just pretend this is what we have, because it is. But what we really want is we don't want the act of compositing the screen, the act of creating the right pixels, to block your UI from running. So what we do is we have a separate thread that runs on the render thread, and it actually walks this unmanaged data structure and figures out the right thing to do. So to communicate between these two things, we have the transport that we talked about, which is a bidirectional messaging pipeline. When you make a change to your UI thread, we send an asynchronous notification to the render thread, and we talk back and forth on that, and we can go both directions such that if we were to run an animation on the composition on the UI thread, which we don't today, just to be clear, we would be able to notify the UI thread of it. We also have another set of data. We have a bunch of little trees. So we have these elements, which are fun, and they're exciting, and we love them. And we have the render data, which is this nice binary stream of goo. And then we have all the other stuff. We have brushes and 3D models and matrices and all these things that form lots of other little graphs and trees that allow you to share data. So you can do things like, I can create back pointers into my element tree using a visual brush. And we take those things and we wire these up together. So some resources, like the data, the actual pixels for an image, we can share between threads. The rest of the stuff we clone between the threads. We actually have the support to directly share some of these structures across the threads, but when we did the performance analysis, the overhead of dealing with those, the locking and all of that stuff was actually was more expensive than just copying this compact binary data between the two contexts. But obviously for images, they're very large, that wasn't practical. So we're now at the point that we have these two threads, these two sets of data, the unmanaged data structures, all of this render information, and we can finally get to the point of actually compositing that, running on the render thread and creating a set of DX surfaces, creating some textures, compositing those together, and finally we let DX do the final present to the display, to the actual display, and we finally have pixels on the screen. Right? Makes sense? Excellent. So far, we've done the typical Microsoft thing, and we've talked to you, but you haven't talked to us. So we need to get the program to listen to the user. So we're going to listen. The user has clicked his mouse. We're going to pretend. You've all clicked your mouse. We have one giant mouse in the room. We go. And the first thing, I talked about how we have an input system even though we use user 32, even though Windows is still there. So what we do is we get a user 32 message, and the first thing we have to do is change it, because we like change. So we convert that from a raw Win32 message into what we call an input report. The input report is our low-level notion of wrapping an actual signal from a hardware device. We take that, and we say, well, if it's a mouse move or it's some sort of mouse input thing, we have to figure out where to go. So we're going to go through and we're going to say, we're going to do a structural hit test on the visuals. We're going to walk that left-hand picture, the UI elements. We're going to walk those and try to figure out where the mouse is. And the first thing we do is we just look at the silly bounding box. We say, oh, it's got to be somewhere inside of there. And if we think it's inside of there, we get this great result, which is hit test maybe. We're not quite sure. So the next thing we do is we look at the geometry data. So you remember we had that shared geometry structure, we had that shared render data between the composition thread and the UI thread. That data, one of the things it contains is kind of the actual geometries that we're going to be rendering inside of. And we use that to determine if we're going to hit the thing. So that way we're not dependent on rectangular shaped things. We figure out where it's going to go, we're great. So now we know the direction we're going, we've got our input report, we want to use the event system. So the event system, we need to create one or more events. Now it's interesting that I say one or more, because, for example, when you move a mouse, even though we just get one mouse move, we're going to generate mouse enter, mouse leave, mouse move, all sorts of events on top of that. So the way the input system works is by taking that report, bunging it around, figuring out all the state it needs to affect, and firing a set of events. And then for each event, we go through and we build the event route. So we talked about the composition system and how input and all the other events run through this entire chain of elements. So we need to build the route, all the elements that will be affected by this. So if you click on a button inside of a panel, inside of a panel, inside of a window, you can actually listen to the button click on the window itself. So we have to build the route. And then we raise the events. We just go to each element, we say, you got clicked, you got clicked, you got clicked, you got clicked. And we now have been clicked. Then you, as a developer, write some code that says if I get the mouse clicked, I want to go tweak this thing, I want to go update this text field, I want to do all this stuff, I manipulate the elements. And we go back to step 4. We've now got a change, we need to go through that whole process all the way again and make the right pixels blink again. So in a nutshell, that's really the entire thing. That's what we do. We take all that stuff, we put it together, and then the next phase is that you guys ask us questions. So Jeff and Greg are going to come up. And basically we've got Greg, who's an architect on the mill team. Right here, he's the one with hair. And he can answer any questions about the low-level parts of the system. And we've got Jeff, he's the one with less hair. And he knows everything about the framework, all about the UI elements, how we do all the transformation, the property system. And we really want to do...
Property system, yes!
Yeah!
All right. Sorry, go ahead.
We really want to do... Thanks, Jeff. I appreciate that. We want to get in and just hear what you guys want to hear about. We want to take this time and get into the details about it. Do you want to hear about how the animation system works, how we deal with timing trees? Do you want to hear about how we host in the browser and how we deal with the hooks into IE6, etc.?
Or why there are white lines and yellow lines, there's arrows in there. What was that all
Yeah,
about?
why there are white and yellow lines and how you go between the two.
That's right.
So if you want to step up to a mic and ask a question, we want to answer them. And if you don't, we can all go partying in LA. Question over here.
Mike here.
Do you do auto layout for localization?
Good question.
The question is, do we do auto layout for localization? Is what you're asking? Is that correct?
Yeah.
Did I hear it right? Well, with the layout system, that one of the fundamental reasons for having the layout system is to get people out of the business of having to say, my button is at 1010, my button is 50 pixels wide, and leaving it to a layout engine who understands sizing the content. And then by the localizers coming in and merely manipulating the content, they will get, the layout system will kick in and will adjust things accordingly. So the goal is, in your markup, as little as possible, specify positions. Use layouts, and the advantage will be localizers have a much easier job. They will change content, and things will lay out accordingly.
In addition, besides just the layout, so we do it automatically for you. And then you can localize the BAML itself. You can actually, that binary format, you can create multiple locale versions of it and replace the whole UI. So if you need to, if you must, you can actually change the layout properties to change it for each locale.
Hi, my question is on BAML. Is that actually included in the EXE, or is it thrown away once you're finished going through it? And the other part of the question is, how much access do we have to these other parts of the system that you've been describing?
You take the first, he takes the second.
Okay, so we're doling out the questions now. We're self-moderating. It's great. So the first question is, does the BAML stay in the EXE, or do we throw it away? The way that the BAML works is that it's a resource. You can think of XAML and BAML very much like RC files of Win32 and the res file, the compiled version of that. And so we keep the binary version in the assembly so we can load it when we need to render. In memory, we toss it out, right? We read it from the file and then we throw it away, so all we have left is the object trees in memory. For the second question of how do you get at all this other good stuff?
Yeah, so for that there's access to some, not to all, and in particular the visual layer. There's an object called a visual that you can manipulate directly, build these trees, the left-hand side trees out of it. There's no access to the unmanaged native code stuff or the composition node stuff that Chris described over.
Keep going. We do a lot of stuff.
Right there.
Okay.
So there is not a direct access to render thread information, but to the visual system, to the visual tree, to being able to create those boxes of render data on the bottom, there is more direct API access for that.
Okay.
Relating to the 3D aspects of Avalon, you guys have meshes, you have lighting capabilities, you have texture capabilities. I was wondering if there was any future implementation plans for shader implementation.
Yeah, shaders is a really promising future direction for us to go. I mean, it's a natural fit in many areas, particularly pixel shaders. For text shaders, a little less clear. That's somewhere where we can go. We've got some great ideas about how that can be incorporated and integrated into the programming model. It's just not here in V1.
Thank you.
Hi, my question regards Avalon from a test automation point of view. I understood that there is, I was in a lecture of UIA, that is interfaces for test automation. Assuming that UIA is not implemented, is Avalon working in a similar way to Win32? I mean, will the controls, all the controls are still Windows, and will I be able to send messages to list controls to get there, to learn how to automate them?
So first, there's only one HWind in any given Avalon app. Or I should say, for every instance of hosting Avalon, there's only one HWind. All the elements are not UI, are not HWind based. They're simply boxes that we keep track of in the visual system. We know how to render them. We know how to hit test them. All of our elements natively support UI automation. UI automation also will allow you to be called through MSAA as well. So basically, UI automation and MSAA are the two ways to be accessible about getting data from inside of an Avalon application. If you don't speak either of those two, you're going to have to implement your own thing.
No, but I mean, if a vendor created an application,
right,
and he did not do anything special in his application to support UIA.
So if you don't do anything, you're going to support UI automation. Our button control natively supports it. You don't have to do any work. You add it to your window, it says, hey, I'm a button, and anybody goes and looks at it with a UIA accessibility tool, and they'll just be able to see it. You don't have to do anything inside your application. It's automatic.
Okay, thanks.
A lot of what we've seen, at least what I've seen on Avalon, talks about the dynamic ways to change the user interface and have very customizable interfaces, styles, and that type of thing. What about the other side of things with standardization and maybe themes that are consistent across applications? Is there any thought in that direction?
So theme-wise, not sure, we didn't really drill into it in the controls talk as much time-wise, but we do support, we have a model for themes that in addition to tying into the themes that you'll see today for Arrow, for Luna, we also have the ability for a control author to participate in this, where in the past, they're kind of out of luck. The control author has the ability to expose, at the time of authoring, here are the different styles that will match these themes, and post-authoring, when a new theme comes out, they can create a new style that matches that theme for their control.
Thank you.
Read my paper. Read Kevin Moore's paper, is what he says.
I forgot that we had shirts for Q&A, so for the people who've already asked questions, I'm going to give you a shirt, and we have a couple more to give away, so keep going, keep asking questions.
Yeah, I have two questions. One is regarding audio, high-resolution audio where you need low latency, such as in multi-track, recording applications, things like that. What kind of considerations are there in the design of this system so that you don't have any loss of audio and you can maintain very high latency? I'm thinking of applications like sonar, things like that.
Yeah, so for applications like that where, well, what we do with audio is we really delegate to the Media Foundation direct show functionality. The composition loop is not involved in rendering audio. It's just pushed out straight through the direct show graph. So whatever is happening through there is effectively the coordination you're going to get. The talk that I gave yesterday, we talked a little bit about synchronization between animation and... Ooh. Talked about synchronization between video and other animation types. And we want to move towards where, we don't have it in the PDC bits, but we want to move towards where we can really use the video as the master timeline to synchronize the animations off of. Professional audio applications, though, I got to say, are unlikely to be served by WPF in its current form, and is probably not the way to go.
Right. I was thinking of where the all this stuff and all the graphics and all the great stuff that's going on could kind of rob the audio system of what it needs to maintain its high throughput.
In terms of
low latency, really high resolution.
Just in terms of CPU usage of
right, or the bus, the graphic, or the buses.
Right. That's going to be up to the application design. I mean, there's certainly many applications that are not require high performance because they don't have stuff going on the screen all the time, and that's just fine. Just like any system, though, you can easily tax the system.
Do you expect dual processor system, say this running, that in some sense because you split up these threads that you're really going to get a big boost on a real multi-core system with your architecture?
Yeah, these two threads in particular run without a great deal of synchronization between the two and can take advantage of that. There's potential for going further in the future as well.
Let's go back and forth.
Is this on?
There we go.
Yes, it is now. The question was, this being such a different model than GDI and GDI Plus, what are the implications for complex rendering? So, we could draw a pretty complex number of objects in our window in GDI, GDI Plus, and now you got this whole framework underneath it. If we got very complex drawing, is that going to use huge amount of memory, or is it going to fail? What's the deal?
Yeah. The main difference between this and GDI and GDI Plus, if we're just looking at it from a rendering aspect, we can kind of remove the discussion of user interface and templating and styling and such, and just go straight to the rendering. The main key difference is that the data structures are maintained by the system. So, and that's important for remoting, for scale, for visual scaling. So there are different characteristics between this and an immediate mode system. It can be compensated that we have mechanisms in the system to let you take a visual tree and render it directly to a bitmap, work with that bitmap, and then throw out your visual tree and continue to work with the bitmap when you get into constrained situations like that.
Is there ways you can tell when you're, how do you know how constrained you're getting? And
Just really, there's nothing built into WPF for that. It's sort of system, just watching system metrics. And
okay.
such.
Do you want a shirt? It's a good question.
And there are performance tools in terms of profiling that.
Yes, that's right.
So there's so you'll have ways of looking and managed, unmanaged, both sides, looking at execution speed as well. We have a white paper on that.
Right, thanks. There was a talk Alexander Stevenson gave yesterday afternoon. I don't know the number of it.
How long are hands-on labs open? Are they done after this? Because it's downloadable. Okay, because the hands-on lab also lets you play with these profilers, but they're downloadable.
Oh, I have a question about the transportation. Since the transportation can be remoted, and if my server do not have hardware support for those shaders, and my client have all those support, can I get those Arrow experience from the client?
The Arrow experience, you'd have to answer, which is the DWM question.
Yeah, there's two directions. There's the Arrow Experience Desktop Window Manager, what gets remoted, and then there's also Avalon and remoting of Avalon. The first one, we're working on that and trying to figure out exactly what the requirements are between server and client. For the second one, what can be remoted for Avalon is pretty much everything. The server requirements are not so relevant because you package up everything into your transport, send it over to the client. That's where it all gets rendered.
Will the server check whether the hardware support in the server side before it can go to those?
I don't think I'm going to look at Leonardo right there. Leonardo can wave his hand. Do you? Okay, the server will check for the client side requirements before it sends it over. It will not look at the server side capabilities because those aren't used.
And just to clarify, since he said he's not mic'd, that's we will in the future, not we do today. So it's where we're trying to get.
Second, I know Avalon uses shaders, but the user are not aware of those shaders. But I just want to see whether the UI thread aware of the shaders or only the render thread.
Yeah, the shaders run on the render thread.
But who construct those shaders?
Those are the instructions, effectively, that are transported across, effectively result in invocation of shaders on the composition thread, but they're built in as the implementation, if you will, of processing these individual instructions.
So the UI thread aware of all those shaders?
No, they're not. They're not. They just say, I want a line drawn. And the line drawing happens on the composition thread however it chooses to do it. It may use a shader, it may not.
The best example of a shader, I think, to talk about this is radial gradient, right? Because radial gradient's implemented as a shader, but you don't know that. That's an implementation detail that we did so that we could get hardware acceleration of a radial gradient. And so there's no constructs really in Avalon to say, I want a shader, here's the shader I want. It's rather an implementation detail of a feature that we have that we expose to our normal API.
The question the gentleman asked earlier about shader support would in fact expose it at the user level. We're not doing that for this version. But without that, there's no sort of user model or programming model that even talks about shaders.
Okay?
Okay, thank you.
Over here.
Two questions. One is, do you have a future version of Rich Edit that support Avalon, or is there a replacement in Avalon for Rich Edit?
Okay, I guess I'll answer that. A future version of Rich Edit that supports Avalon, I don't know of one, so I would, if you'd like to go write one, we'd love to see it. Out of the box in Avalon, we have the rich text box control, which is effectively a rich edit in an element. So that's where we would think you'd do it. It's missing some of the object model that we're planning in V1 isn't enough to do a simple data binding based UI around it. But we do have a sample internally that's effectively WordPad written in Avalon that does all of the right features, does all of the goo around the Chrome of it. The control itself has all the features necessary, though, so you can write up to a WordPad-style application.
So does it support TOM, text object model?
No, we have a different object model for dealing with text. We actually have two object models for dealing with text at a low level. We have a collection-based text object model that feels a lot like the rest of Avalon. So a paragraph has an inlines collection that you can add runs to with bolds, etc. And then you have what we'd call the streaming text OM, which is a text pointer marker model that you can move through the text stream and you can do linear walks. But we don't have the COM-based TOM interface that Rich Edit supported.
Okay. Second question. Suppose I have existing WinForm control I want to use in an Avalon app. How does it fit in the picture you have here? Especially, you mentioned there is only one H1 in Avalon app. And every WinForm control has a H1.
If you host a WinForms control, there's now two. So when you add an HWin, when you add any HWin, whether that's implemented in WinForms or as an ActiveX control or as a MFC thing or whatever, we just give you a little box and you put your HWin inside of there, and it would show up in this picture as another element, and we'll cut out a spot for you to render in. We'll get we'll let user 32 do the compositing of that, right? I'm looking for confirmation from Greg.
Yes.
Yes.
Yes, that's exactly
We're just making sure.
I'll say
as
yes.
long as we all agree, we're pretty sure it's right. We're trying to make up less stuff.
Yeah, this is where the two window managers are working together. It cuts out a hole. Avalon's window manager there cuts out a hole and says, user, take it from here, and it renders in the classic GDI user fashion.
And then the way that's hosted programmatically is there's a WinForms integration assembly that does the transition from the Avalon layout world into the Win32 world so that we know where the hole is to punch out.
So
there's a hands-on lab on doing this.
Oh, okay.
Great.
The interop between Avalon and the WinForm control, is that expensive?
The interop between it, is it expensive? Two? No, I don't know how to measure it. We have to do some translation of layout. We have to do some input translation so the two systems understand where they're going.
I think it's a pretty efficient bridge. I don't think that there's, but certainly play around and let us know if you find anything, because I don't think you're going to hit much performance there.
Okay.
Much performance issue.
Thanks.
Mm-hmm. Sure. Ooh, close. Overshot.
Okay, a lot of the demos we've seen this week have done some really impressive 2D and 3D mixing together within an Avalon app. It's going to come to a point for a lot of us when we're going to start to push the limits, I would imagine, of what Avalon can do with 3D in terms of scalability. Are there going to be guidelines for when we need to start looking at, okay, I need to turn this into a real direct 3D app, and can we host a direct 3D window inside of an Avalon app directly?
Right. Okay, yeah, so second question first, hosting direct 3D. The hosting, again, is at the HWin level, so you can readily host a direct 3D window, and I think Nick Kramer in his talk had a demonstration that did that. And the hands-on lab.
Wow. That can't be the answer for everything.
Now, that's the That's the window hosting. There's another level of hosting that's not supported, which is DirectX surface hosting, which we ultimately would like to do as well. And that would allow for richer interactions there. As far as guidelines on when to stop using WPF and start using Direct3D, we do want to make some guidance available on that. You know, there's sort of broad guidance of don't implement your Twitch games, for instance, in WPF.
Avalon Quake is coming out.
Avalon Quake's coming out next week, right?
I think it's great.
But the other thing about that is we shouldn't really be hampered by mesh size. So meshes translate directly into Direct3D meshes, which we then use. What we will be more hampered by is complexity of model tree, for instance, in the Avalon space. So you can have pretty complex models with single nodes as well complex trees. But you're right, at some point you're going to get to that point.
Thank you.
Sure.
Shirt. Oh, last shirt.
Last shirt.
Oh.
Give me the box.
No.
Okay, so since we're out of shirts, give me the box. Since we're out of shirts, we're going to do sudden death questions. We're now at this point going to have to vote on the best question. There's one more present. This is from the Weston Bonaventure. This is the coolest thing we found this entire week. Look at the blinky lights on the bottom. So there we go. So I'll put this up here. This is something you guys can focus on when you're asking the questions is think if your question is going to be worthy of that.
Eyes on the prize.
Eyes on the prize.
It's demonstrating animation, gradients, 3D support.
Yeah, 3D. Look. Ooh.
Yeah. Translucency, yes. Glass. It's aero glass. That's what it is.
Yes.
Okay.
All right.
First entrance in a sudden death question.
How would the current code run on the final build of Avalon? If I have an application that runs slow now, how would it scale with the final release?
If you have an app that's slow now, will it be slow when we ship? Is that the question?
Yeah, but how much? Maybe it will be a bit fast because your code will improve.
It better be faster. My job until we ship, we've got a team together. My job until we ship is nothing but performance. So you try stuff out. If something's slow, send it to us. Tell us what it is. We'll add it to our list. We'll take a look if it's known, and if it's not known, we'll add it in and make sure we address it. We have focused on performance to some degree, but to this point we have tried to get all the features built up, and now it's time to make sure. Now we're in a good spot where we're doing less of the forward progress and more of refinement. This is a fine time for us to dig in on the performance. I'd like to guarantee the answer is that it's faster. I hope. And that's where we need your guys' help. Try stuff out. Tell us what's slow. That's the only way we're going to make it faster. How do they tell us? News group, WPF perf.
Hands-on lab?
At Microsoft.com. And the hands-on lab, yes. Yeah. Ooh. You got a job here.
Okay, so that's entrance one.
Entrance
Will
one.
my slow app
be we have to keep track of these somewhere.
faster?
Okay, all right.
Okay.
We're going to keep track of
Okay, I have two questions.
We're doing it's sudden death now. We've got rules about this stuff. You get one question, one entrance.
I'll forfeit the option for the glass.
Oh, okay. All right.
You described the process of taking the XAML file and turning it into BAML and then exe. Is there access to a parser and serializer where you can just dynamically load the XAML file and render?
So the question is, can you dynamically load XAML files? Yeah, there's in the system Windows serialization namespace. That's in the PDC bits. That's what it's called. We're transitioning to a new namespace in the next release, which will be called markup. There's a parser object which can save and load XAML from a running tree and create a running tree out of it.
Okay. The second question: at one of the previous sessions, it was shown some of the 2D bitmap effects. I guess there was just two of them: blur and drop shadow.
Whopping two.
What other ones are you planning?
We would tell you, but we'd have to take you out back. They're so secret. We're going to do probably a blur and a shadow and another blur and then some more shadows and then. No, do we have any other the effects that we know about that we're going to put in? There's 42 of them in the current builds.
More than that. There's 48.
Oh, 48. Wow. So basically, we can't even get the people who work on the team. So 48. Yeah. Hands-on lab. Okay.
There's a theme.
We're here.
All right. Yes. We heard that several people asking about hosting controls, particularly HWind. What happens if that HWind happened to be an OpenGL viewport?
So there's, I think I know where you're going, but there's sort of two answers. There's Avalon, because Avalon runs on Windows XP and Windows 2003 Server and Windows Vista. On XP and Windows Vista, on XP and Server 2003, in the classic window manager, it'll host just like any other window. I'm pretty sure. Nods?
Okay.
Yeah.
Yes.
Yes. In Windows Vista, because of the way the desktop window manager works and the way applications are redirected to secondary surfaces off screen, OpenGL ICDs don't do that. So the hosting will still work, but what'll happen is you will temporarily lose some of the blur features and glass features on your window. But with respect to your question, the hosting of the OGL application inside of the Avalon will be just fine in that case.
All right, thank you.
Okay. Wait. Talk into my neck.
I'll talk into Chris's neck. So the one thing I'll add is there is a Microsoft ICD that will be in Windows Vista that supports OpenGL 1.4. So if you're not using any of the beyond 1.4 features, you'll be able to run with hardware acceleration for your OpenGL apps. If you install a third-party ICD, that's when the process that Greg described kicks in.
And that ICD, the reason that ICD works is because it redirects into DirectX, which then redirects its surfaces.
There's a lot of uses of the word direct.
Redirects.
All right.
Directly.
Yeah.
Direct,
Yeah.
redirecting.
Redirect. We're going to come out redirect.
I'd like to redirect to this side now.
Is there a way of pre- or post-processing the rendered image, for instance, to change the layout to add your own glass effect, or even render it to another service?
So well, as far as layout goes, not really, because layout is a pre-rendering process that occurs as far as positioning items, unless you have some smarts that's able to cut up the image. But as far as post-processing images, absolutely. One is that the whole bitmap effects architecture is all about being able to attach effects, either these ones that we talked about currently to, in the future, 48, effects to any node in the visual tree. What happens is WPF renders that. We send it through the effect to be bitmap processed, and then take the result of that and send it the rest of the way. So that's how effects work. And then you can also take any visual tree and render it through a render bitmap target, render target bitmap. For a render target bitmap
target, which that would have been nonsense.
Yeah.
Yeah. Okay.
You can render through a render target bitmap just to a chunk of memory that you provide.
Otherwise known as the RTB.
And then do whatever you want with that.
So you could again display it in a really displayed scene.
I'm sorry, can you say that again?
So you could use it as a material or a texture on something in the
Yes,
actual
because
scene.
that render target bitmap, what it renders to is a bitmap source, which you can then incorporate into your scene again. Okay. But you often don't need to do that, because you can use something like Visual Brush to provide a direct path, a direct pointer into that thing in the first place, without you having to worry about rendering it. And that's really the first
I can imagine you could create your own client app that renders the transported information to somewhere in your window instead of pushing it onto your entire screen.
Yeah, and render it somewhere else. I've talked to people this week about how you encode it to video, for instance. You can use that for facility for this sort of thing.
Great.
Thank you.
Thanks.
Next question?
I also have two questions. You can pick the worst of which for Martin qualification.
Oh.
One of them has to deal with performance, and I'm just trying to understand when you have a whole bunch of effects and transformations going on at the same time. I mean, Avalon obviously allows you to do a whole bunch of complex operations. Are those all being collapsed down to a single operation or as small as possible so that you only render the pixel once? Or are they actually rendering all the intermediate steps in off-screen memory and doing that?
That's another one where it currently is and will be for the foreseeable future a story where we can do some we do some stuff now, and there's lots of opportunities to do stuff now in the future. In fact, we do a lot now in terms of occlusion culling of things that are not visible behind other objects, dirty rectangle management so that you only update the area of the screen that has been dirtied, awareness of you apply opacity of 0 to something, you don't need to render that anymore. So there's many optimizations in the system
A lot
that
of
we do.
the operations are linear transformations that can just be piled on top of each other as a single.
Well, in fact, yeah. In fact, we accumulate transformations before applying them.
Okay,
in that particular example.
And the second question is a little more philosophical. It's presentation platform, but all I hear about is pictures. Audio is more than, or sound is more than just playing WAV files, just like audio, pictures is more than just showing.
So there's actually I totally agree with you. Part of the platform is actually the system.speech API. So you can actually do both speech input and speech generation with the framework as well. So there's a full support to be able to do that. You can write prompt APIs. You can say that I want to ask a person a question. This is the kind of data I want to ask for them. You can give them a list of things. They have both I'm going to stretch my knowledge here. I don't know if it's on Vista only or not, but they do have both the database approach to the phenom recognition as well as the mathematical or the algorithmic approach to it. So we definitely agree with you 100%.
Well, I'm also looking at much more tools that use sound as a presenting a more natural interface to the user than just that. Like, for example, a simple application would be if I click on the left side of the screen, I'd like to click more from the left speaker, right from the right. If I'm far away from something, I'd like to hear some echoing. The graphics processors gave us a lot of capability you weren't using prior. The sound processors give you sound cards give you a lot of capabilities that you don't take advantage of at all. And if you're trying to get an emotional response from the user, having the different senses coordinated will give you much better.
That's a great point.
Is there anything happening with that? Or?
There's support for audio playback, and there's support for sort of triggered audio based upon events and such. But further than that, no. And we have certainly thought about some of these.
Because like music generation is one that is way behind.
Sure. Mm-hmm.
We have a vote for giving him the glass. That's a lot of. That's good. Okay.
Earlier I asked. Well, someone mentioned that we could
going
access.
For a second one. That's greedy. That's just greedy. You're going for a second. Jeez. No, go ahead.
It was mentioned earlier that we have access to the higher UI thread to those to the modules, but we don't have access to do anything to the render thread because it's unmanaged.
No, not because it's unmanaged. That's not the reason.
Just because it's your render.
Yes. I just want to be crisp about the difference between the two things. But yeah.
Do you think in the future it would be possible? Well, I guess anything's possible, but.
Yeah.
All right. To maybe have access to that in a managed way, or maybe even inherit from that, so we could possibly implement our own type of render system that would have the capabilities of, the current Windows or Avalon render system, but maybe add on. And the gentleman mentioned earlier regarding DirectX, when do we step from Avalon to go to DirectX? If we could override or inherit from that, we wouldn't necessarily have to step over to DirectX. We could apply our own methods that handle render situations in different ways.
Right. Yeah, that's a direction we've also talked about. It could be, but some of the complexities here are also that as a platform, we make a number of promises. We promise we're able to remote things. We promise we're able to print things. And in order to do those, you kind of have to have more. You have to be able to transport those custom renders, for instance, across machines, which then makes the problem quite a bit more complex. So that's why we're not doing anything this time around. In the future, can. I've also got some late breaking news. There's WPF posters on one of those tables back there. Which one? Far one? Far table back there. So,
but they're not as cool as the glass. They're very cool, but focus on the prize.
Thank you. Next question.
I have some question on the printing related to. So the printing is like a very important action now in the new platform. So it used to be we have to print outside the sandbox. So in printing the browser, you have to do ActiveX control. How does the rights associated with that printing? And also, when you do printing, is every document default they have the printing capability? How do you do the pagination? Like, how do you kind of cut in the right spot and that kind of thing? do you have to do special work for each document? Are you trying to throw our reporting business out of business or something? Or?
So I'll start with the last question first. So as far as printing support and pagination, it's a built-in feature of the platform. There's nothing additionally you have to do. So the flow document type knows how to paginate itself intelligently. You can actually, on Paragraph, there's properties like keep with next, and you can do all sorts of management of the, to prevent orphans and things like that. The columnization, all those things are built-in features of our content elements that we have that are part of the document layout. So that's all built in. You don't have to do extra work for pagination. UI element side, so if you're creating list boxes and buttons and things like those are tied to a single visual area, and so you're going to get generally clipping or poster printing behavior as opposed to actual pagination with them. But again, the document types actually natively support pagination.
So any document, they can automatically...
Yes, any document, anything that's implemented inside of a flow document type will work, which is basically what the rich text box is basically a flow document editor. As far as printing in the sandbox, I'm looking around if that's in this build or not. Not in this build. It's something we want to do. There's a bunch of issues around. Do you let people print arbitrary goo to the printer? Is prompting them enough? The features that enable you to do printing are not the issue. It's more of the user model around how they deal with printer management. So we're looking at the right way to do that.
So you're relaxing the security? That used to be?
Not relaxing the security, more of figuring out the right user model that might allow people to access printers in a safe and secure way.
What if the printer on the network? So do you have an issue with that? The printer on the network, so do you have special rights checking, that kind of thing?
I'm trying to go back. In .NET 1.0, you can print programmatically using the print dialog to anything. So if you use a WinForms control inside the browser, you can print out, provided you pop the UI. And then the user picks what they want to print, and you're good. Default printing is, I believe you always have to show the dialog in WinForms. I'd have to double check. But that's the kind of thing we're looking at as well. So, Mr. Griffiths.
So earlier you mentioned how you take your 2D parameters and turn them into triangles so that the graphics card can have an easy time to render them. There are some situations where I'd like to draw a 2D primitive, but for various reasons I want to bring my own triangle list. I've got nothing against yours. Some of my favorite triangle lists are generated by WPF, but for certain kinds of drawing effects, there are things you can't do easily with maybe fills or radial fills or whatever, and it's useful to be able to bring your own triangle list, which you can do with a viewport 3D and bring your mesh. But there's two problems with that. One of which is I'm dealing with a load of 2D stuff that I don't really want because it's, a load of 3D stuff like the camera position and lighting that I don't really want because I'm just drawing something in 2D. And it doesn't get anti-aliased, so it looks kind of out of place. It doesn't look like a proper drawing primitive. So what are my options for bringing my own triangle list? Do I have to go to the hands-on labs or?
If it were only that easy. So, yeah. Well, there is going to be addition of anti-aliasing support for 3D, so that should help with a 3D issue. It won't help with having to set up your scene for 3D. For that, I think, but I think that really is the way to go for V1 because that's the functionality we have. Certainly a 2D mesh primitive would be a viable thing to do. We don't have it in V1. It's certainly something we'd like to look at, something we've considered in the past. But I think the way to go is through the 3D mechanisms. Any other thoughts on that? So.
I got the one. Use my own favorite track.
Okay. Thanks.
Hey, is the native rendering system the same between the Vista version versus the XP and Server 2003 version?
Yes.
Same version
Next
of
question.
D3D using hardware acceleration?
Same. Well, it uses D3D9L, but it doesn't use any additional features of that. Right? No additional feature usage of D3D? Yeah, so it's the same.
Okay, and are there any issues using acceleration on XP because it has the different driver model, may have different
Well, acceleration on XP means that we're not going to get the virtualization of the GPU that the Longhorn display driver model gives. So that may result in issue with contention between multiple Avalon applications or Avalon and other DirectX applications. But that's purely a kind of driver system issue. I mean, machine characteristics based upon where the drivers are at.
Right. Okay.
You say that the UI is remotable with this transport.
I was wondering if there's any way, is that only going to be used in like a terminal server scenario, or will you be able to programmatically open 5 displays or something like that and display all your stuff on multiple machines, like an X Windows?
Leonardo really wants to answer that question. What? Oh, that's you got the glass for as far as Leonardo's concerned. Right. The exposure for that is really for terminal services. I believe it's going to be available under a licensing API access to that stream is going to be available through some licensing agreement that other remote terminal manufacturers will participate in.
Why is that?
Sorry?
Why is that?
Why is that in terms of...
Why do we want people to get access to the protocol?
No, why don't you want people to get access to the protocol?
Yeah, why is that a license update? Yeah. Paulo, you want to?
Well, just a second. Ian, do you want to come up and Ian's going to help answer that with the here, I can give
Talking to his neck. Talking to his neck.
It's a great question. What we're still debating the licensing for the protocol streams. It's more a business question. We're going down the path that we've done previously for TS and RDP like protocols. So we're basically just going down the same path that we've always done. That's always been separately licensed. Now, the terms of that, we have no idea. We have to go figure that out.
It's actually kind of my question as well. Is there going to be an API that will allow me to host the rendering thread?
API to host the...
Yeah, that's the same. It's the
same question, really. It's,
right. Yeah.
So if he gets the glass, you have to break it in half.
Okay, no, it's okay. It's,
okay.
Anyhow, I can't carry it.
I'm sorry. The answer to that question is really the same. The mechanisms for accessing that stream are going to be under the same terms as those for producing or consuming a stream are going to be.
And by the way, that's the way the Xbox 360 is going to basically show Avalon Experience, the media extender.
Yeah, I don't know if there's any.
That's what they said
decided
yesterday in the
certain plans. Do you have any further on that? Yeah.
Yesterday, at least the media center guy announced that you will be able to see any Avalon application on the Xbox.
Yeah, the Xbox is going to have a media center extender, which is effectively a TS client, and so you'll be able to remote through TS. Now, whether or not they're hosting the transport, the render thread on their box, that's a different discussion, which I don't know. I just don't know their product plans. But they will support it through the TS mechanism.
It's not a TS because, for example, GDI application cannot run on the Xbox. It's only HTML tags and Avalon. That's what they said. Yeah. So it looks to me like they're running this. Makes sense also from performance.
We'll have to talk to them. I just don't have the context on it.
Yeah.
Sorry. Apologize.
So Avalon on XP and Avalon on Vista, is there any difference between them in terms of functionality and performance and look and feel?
There were 3 subparts. Programming model, no differences in programming model. Performance, what you're going to get with Vista's LDDM, which really does it. It helps scheduling, it helps resource management, but that doesn't help performance. And the third was styling.
The visual look and feel.
Visual look and feel is, also that's...
Well, no, it will be different. It will be different because the Vista has a new theme, which is Arrow, so you'll get the Arrow look on Vista, which you would not get on XP. On XP, you'll get Luna. But your custom styling would look identical on the 2 different machines.
Right. So Avalon on XP, that will be a free redistributable?
Yes.
To my knowledge. Yes. Okay. Yes.
Okay.
We .NET Framework goes free. All of the runtimes, all of our runtimes go free. So.
Any idea?
You have to buy Windows. It's included with your Windows license.
Any idea how big the redistributable package is?
Redistribution of it? You're asking how we model
there'll be a redist for it.
No, how big?
I think right now it's about 14 megs minus the .NET Framework 2.0. I think it's around
14 compresses to 12. It's 14 compressed to 12.
12 compressed.
Okay. Thanks.
All right.
Okay. Next question. or last question.
I'm just curious about, does Avalon take advantage of multiple GPU, say NVIDIA's SLI or ATI's Crossfire?
Cam's nodding his head, yes. Just
at our level, I'll echo for Cam. At our level, it looks like one GPU, so yes. They do that all in the hardware.
The driver takes care of that, that work, and we just talk to the driver.
So you guys have mentioned about GPU virtualization. So you got a scheduler. Then for you guys, it's still one GPU. So you're scheduling on that one GPU. Is that correct?
Well, it's not WPF that's doing any scheduling. The Longhorn display driver model is what's responsible for doing the scheduling, and it provides the view to all users of that driver model that they own the driver, just like the virtual memory system and the CPU and the system. So what's being virtualized is the memory on the GPU, so that you won't get out of surface lost messages from DirectX and the GPU time slicing. But that's all handled at the driver layer, and we're just a client on top of that.
Okay. So I think with that, it's time to award the glass.
It's time to award the glass, and there were so many good questions.
There were.
I know how InXS feels right now. I think what do you think about that one?
I'm wondering about the NXS reference.
Oh, that's a reality show. You're not hip to that. Kids, what age are your kids? How about the what do you think? Audio support? Audio support. What do you think?
Audio support.
Why the crap don't we have audio support, huh? Where are you? Come up here and claim your glass. Not only with the box and with the authentic Westin hotels and resorts right there. I'll turn it off to save your battery. Please enjoy your drinking of non-alcoholic or other beverages.
I'll give it some thorough testing.
Yeah. So we kind of took, we wanted to take this time to give you guys a chance to ask us the questions, to dig into the architecture, to talk about some of the stuff that's under the hood so that you could really get into the details of the platform and understand some of the nuts and bolts of how the system works. We really appreciate all the time you guys have spent this entire week. We've really enjoyed it. This is the thing that really drives us as a product team to be able to ship, is getting to engage with you guys, getting to hear your questions, getting your feedback. We definitely desperately post to the forums, post on your blogs. Just send us your feedback any way you feel best. We really want to hear it. We want to hear what's working, what's not working. That's really important. Speaking of that, I'm legally required to say, please fill out your session evals so you can tell us if you like this forum or not. Is this a good format? Should we ever do this again? Are we horrible and should ever be on stage? That's fine. But thank you for coming, and enjoy the rest of the conference.